ahead and start the recording so I don't forget it this time. When we wrapped up on Monday, I said, think about whether or not we want to talk about one of the exam one things. What were we looking at? Compositions. Do y'all need a composition problem or do you feel okay with it? Composition problem? No composition problem? You'll know what I mean by that? Can y'all hear me? Yeah, we're good.
Mic not working.
I don't think it is. We're good. Yeah, I got a thumbs up.
Okay, good.
Okay, so a couple of thumbs up. Good, guys. Thanks. All right, so do we need a composition problem or no? Yes, okay. We're gonna do one of those and then we will jump onto the test 2 material. All right, and then for Friday, I have a video for the Friday test 3 material stuff. And then that is it. We're looking at taking the test next Wednesday. Yay. We'll see how that goes. And I have to work with Miss Mason. Is Miss Mason there today? Still not there? Okay. So I'm gonna work with her hopefully to get y'all set up for the 2-hour block for Wednesday. And she was saying 10 a.m. and I don't remember which class period that is for y'all that y'all would have to kind of get out of, but she had already looked at y'all's schedules, class 3. Okay. So she looked at y'all schedules to try to get y'all back to back 3 and 4. Okay. So we'll see how that goes. I'll try to make it work. Okay, so here we go. Let's do a composition problem. I'm looking at the number 15 on the test review. I'm still doing the white one with Adam Bowden by Adam Bowden. If you're wanting to do stuff on your own, you can do the ones we don't do, or you can look at the green test review. That's the one I would study the most, is the green one, because I feel like that's going to be the most like what the person who's writing the final is going to give us. So number 15 says f of x equals 9x squared minus 2x, and g of x equals 17x minus 9. Okay, so I've got those two functions right there, and we want to do f of g of 9. Okay. So if you'll remember that this fog stuff or GOF stuff, this composition, this little sign right here means composed of. Composed of. Okay, what it means is whatever I see there, I'm going to plug in. Well, so the 9 is going to go into the G function. And then whatever I get out of that, that G of 9 is going to go into the F function. So the equivalency looks like F of G of 9, right? So G of 9, plug that in, and then plug in whatever I get from that into the F guy, okay? So let's go. So G of 9 looks like 17 times 9 minus 9, okay? Plug in a 9 wherever I see the X guy. So do that on my, oops, not log. 17 times 9, I've got 153 minus 9. And that's giving me 144. Okay. So I'm looking at number 15 and I'm thinking, okay, I've got this part right here as 144, but we're not finished yet, because then we have to take whatever we got there and plug that into the F, right? Now this one's actually going to be a little bit nice for me because I've got a number here, right? So if it hadn't have been a number in there, if it had just been G of X, then I'd have all of this stuff to plug in, the 17X minus the 9. But because I have a number, it's not going to be too terribly horrible. So now we're going to take this guy, 144 and plug it in for the F, right? So that's going to look like F of 144. Well, that is 9 times. The X here is 144 squared minus the 2 times 144. Okay, so now that just becomes plug it in and do the multiplication basically, right? So 144, 144 squared. That's 20,736. So this is 9 times 20,736. And I can do that times the 9. And you don't have to do as many steps as I do. I know I tend to break it down into every single step, but I want you to see where I got all the different numbers from. So if you know how to plug that on your calculator, just show me the plug-in step so that I can see what work you're doing. Okay, I substituted in 144 into the guy, so show me at least this step, right? So I see what you did. And then if you can plug the rest of that on your calculator and not have to worry about it, then fine. Okay, so I've got 186,624 minus the 288. And so I'm going to just punch that real fast. And I get 186,336. Okay, that's F of G of 9. That's my answer. Okay. Double check because we have the solutions key, so we might as well check it. Yep, that's what he had. So I like it when that happens. Y'all remember compositions? Yeah. Okay. So that's most of the exam 1 material from what we did on Monday plus this. So if you feel pretty confident with that, then we're going to move on to test 2 unless somebody has something they want me to show. Nope. Okay. All right, so I think that the test 2 material starts around problem number 19 on this test review. So that's the average rate of change. And again, we've done this. I feel like you should have it in your database somewhere, but maybe it's been a while. So we probably just need to refresh ourselves. So test 2 material number 19. Okay. It says f of x equals square root of 2x, and they're doing from x1 equals 2 to x2 equals 8. Okay, and it says find the average rate of change. And I'm going to cheat and call that AROC, average rate of change, like we've done that in the past. Okay, so remember that average rate of change is basically like we're finding the slope of the straight line through the 2 points. Okay. Even though the function is not straight. So we're approximating, that's what we're doing. Okay, so we're finding the slope of the straight line through the 2 points, even though the function is not straight. So what does that mean? So whenever I look at this function, and I'm not going to do it myself, I'm just going to graph it on the thing. Let me clear that out. Okay, f of x equals the square root of 2x. Okay, and I see that graph. It looks like that, right? So my graph here, something like this. Okay. And it's kind of straightish, but we know that it's curved. So what we're doing when we find the average rate of change is we're looking for the points between the first guy, which was x equals 2, okay, right here, and the second guy, which they said was going to be, let me scoot this just a little bit. They said was going to be x equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's going to be up there somewhere. And basically, we're going to deal with the straight line that goes through there, even though our graph is curved. Okay, because look, the straight line looks kind of like it's gonna approximate that curve, right? So we're gonna do that. Now, what you have to do though, is we have to have 2 points, right? And then we'll deal with the equation for slope in a second. But we say, hey, we have the point x equals 2. We don't know what that y value is. And we have the point where x equals 8, and we don't know what that y value is. So before we can use slope, okay, we need both points. So they only gave me x equals 2, or x1 is 2 and x2 is 8. That's all they gave me. So I need those points, okay, so that I can find the slope. Slope requires 2 points. So we're going to find f of 2. Okay, because my x is 2, right? So that's the square root of 2 times the 2. Okay. Well, that's the square root of 4. And we know that that's going to be positive 2. Okay. And again, we can look at this graph here and see we're only dealing with the positive values. We don't have any negatives down there, right? So that first point is 2, 2. Okay. And then we need the other one, which is f of 8. And if I plug in an 8 there, I get the square root of 2 times 8. But 2 times 8 is 16. So this is the square root of 16. And fortunately for us, that's another one that we can take very easily. Square root of 16 is 4, right? Okay. So we've got the point 8, 4. Okay. So those are my 2 points. You have to find them first, right? They're not giving you the y value. So that's why we have this function, okay, given to us, is so that we can find the y values. But I got those 2 points, and now I need to find the slope, okay? So remember slope formula, that's the M guy. Y2 minus Y1 over X2 minus X1, okay? And in order to do that, I have those 2 points up there. I'm just going to call the 2, 2. Those are going to be my first points. So this is going to be my X1, Y1, right? And the 8, 4, that's going to be my second point. So this is going to be X2, Y2. Okay. All right, so plugging in, the Y2 minus Y1 is going to be 4 minus 2. And then the X2 minus X1 is going to be 8 minus 2. And remember, it doesn't really matter which one you call your first point and your second point as long as you're consistent. You always start with the same point. So I started with the 4 here. I start with the 8 here because those 2 are in the same point. All right. So now 4 minus 2 is 2. 8 minus 2 is 6. 2, 6 is 1/3. Okay. So my average rate of change between these 2 points is 1/3. Does this kind of sound familiar? I know it's been a while. It's probably been 2 months since we did this stuff. So you gotta put it all back together at some point. And I just checked, and that's his answer on the answer key. So we are golden. All right, let's move this up. Okie doke, here we go. All right, so we had some average rate of change stuff. I'll let you do number 20 if you want some practice on that. X-intercepts and Y-intercepts. I feel like you guys should be able to do that, but we'll do one for sure where we have to do that. And then let's talk about the vertex. Okay, so again, 21 and 22. I'm going to do the first one. I'll let y'all do the second one by yourselves. So it says f of x equals x squared plus 8x plus 7. Okay. Remember, test 2 was kind of the big exam. It had all the polynomials and rationals. So there's lots of function stuff in here. Okay. So I need the vertex, and then I need the x-intercept and the y-intercept. So let's start with vertex. Okay. There's a formula that said for your vertex, your x value is always negative b over 2a. Right? So I need to kind of look at this guy for just a second, and I need to come out to the side. Even if you're stuck on a problem, at least tell me what you know, right? So I know that the a here is a 1, right? Because that's the number out in front of the x squared. And then the B here is the number in front of the X, so that's an 8. B is 8. And the C here is my constant, so that's a 7. So if you don't know anything else, you definitely know my A is 1, my B is 8, my C is 7. So if you know that, hopefully you can use this little formula, X equals negative B over 2A, and plug in there. So let's do that. X equals negative is in the formula. The B is 8. Okay. Over 2 is in the formula, and the A is a 1. Okay. So negative 8 on the top and a 2 on the bottom, that's going to be negative 4, right? That's my X value, okay? So we always can find that one with the negative B over 2A, but I need to find the Y value because the vertex is going to be a point, right? So it's negative 4 and then whatever the Y value is. So this is a lot of plugging in stuff, okay? We've done it before. Just remember, plug in again. So to find that, I'm going to do f of 4, which is going to be 4 squared plus 8 times 4 plus 7. And again, even if you don't show me anything, at least show me the plug-in steps so that I know you were on the right track when you did it, right? So this is going to equal 4 squared is 16. 8 times 4 is 24. And oh, no, that is not true. Don't let me lie to you. 8 times 4 is 32, right? Keep me honest here. 8 times 4 is 32 and 7. So now I have to double check 8 times 4 because I messed it up. Okay, so I've got 16 plus 32 plus 7, and that is 55. Okay, and that's my Y value. So there it goes. Here's my vertex. Okay. Everybody feel like they can use that negative B over 2A formula and then plug back in, get your vertex? Hope so. All right, there we go. So that's 21. We also need the X-intercepts and the Y-intercepts. So for X-intercept, remember for both of these, you always plug in 0 for the opposite guy. So I want the X-intercept, I'm going to plug in 0 for the Y. Okay. So to get my X-intercept, I'm going to plug in 0 for my Y. Now, my Y is the f of x guy out here, right? That's the same thing. So this is going to be 0 equals, because I'm going to plug in 0 for the f of x or the Y, x squared plus 8x plus 7. Okay. And a ton of these will factor, but occasionally you'll have one that doesn't factor. So if you run into one that doesn't factor, you're going to use quadratic formula. But hopefully you're looking at this one going, I think that factors. Okay. And it does factor, right? It's going to be x and x. And tell me factors that, or two things that multiply to give me 7, but add up to give me 8. It's a 7 and the 1, right? And because these are all positive, it doesn't matter which order I put them in. So just check yourself for a second. X squared plus 1x plus 7x, that's going to give me the 8x, and then plus 7. Okay. That factoring, man, is never going away. It's always going to stick with us. All right, so then I know, okay, either 0 equals x plus 7 or 0 equals x plus 1. We've been doing this solving thing for a very long time, so I'm hoping you tell me x equals negative 7 or x equals negative 1 because you subtracted 1 from both sides. Does that sound familiar? We're good? Okay. All right, so then what about Y-intercepts? It's the same thing, but to find the Y-intercept, we plug in 0 for, again, it's the opposite variable, so I'm going to plug it in for x. Okay. So this is going to look like y equals 0 squared plus 8 times 0 plus 7. Well, 0 squared is 0, and 8 times 0 is 0, and plus 7 just gives me a 7. Okay. So I am very, very happy with you guys if you can get that far. and tell me these are my Y-intercepts and my X-intercepts. The only thing you might need to watch out for on the exam is that the directions might say, give it as a point. Give as points. Okay, if they say give me points, then it's really not terrible. You just change these into a points. So it'll be -7, and remember that to get that -7, I plugged in 0 for the Y. So -7, 0, and -1, and that one was also a 0 for the Y. And then this guy was Y equals 7. So it would be something 7, and remember to get that, I plugged in 0 for the X, so it's 0, 7. So it's possible you might be asked to give those as points. If you don't completely follow directions, you might lose a point for that. But if you get to the -7, -1, and Y-intercept is 7, I'm going to be really happy with you. Okay, so do as much of that as we can. Sound familiar? Okay, and then I start seeing several things in there. So I'm going to kind of try to combine some of these into one, like we talked about before. So let me look. I see 23, 24, 25, 26. All of those deal with the fact that we need to have degree, we need to have multiplicity. One says, does it cross the axis or does it touch the axis? And then one says, sketch the basic graph of the function by showing all the intercepts and the proper end behavior. So I just want to do one of those, and I'm going to hit all of those things with one. So I'm looking at number 26 because it looks kind of the most complicated for me. So I'm going to pick that guy. The nice thing about this type of problem is that they're normally going to be already factored for us. So they did a step for us, which is nice. So 26 says f of x equals x plus 2 in parentheses times x plus 3 in parentheses times x plus 5 squared. Okay. So, all right, looking at that, and I'm going, let's start with the beginning. The beginning says, determine the degree of the polynomial. And remember, degree is the total exponents on the x. And I remember on the test number 2, that some of you missed this one because we didn't have the exponents that are on these little factors. So this is x plus 2 here. And remember that the exponent on it is a 1. Okay. If there's nothing up there, it's always a 1. Okay. This is x plus 3, and his exponent is a 1. Okay. And of course, the x plus 5 has a 2 up there. So my total exponents is a 1 plus a 1 plus a 2, okay, or 4. So my degree here is a 4. All right. So that's the first thing it asked for. And then the second thing said, find all the zeros and give their multiplicities. Now, zeros, remember that means the same as solutions, or the same as X-intercepts, or the same as roots. All of those are the same word. So to find my X-intercepts, we just did one of these, right? We make the y be equal to 0. 0 equals x plus 2 times x plus 3 times x plus 5 squared. Okay, so we make the y be equal to 0, and then we just solve those. So find all the different roots. And we should have a total of 4 roots because the degree is 4, right? So 4 roots is what I'm looking for. Okay. And I think this multiplicity thing bugged some people. So we're going to make sure we talk about it. Okay. So to find my solutions, my roots, my zeros, I put them each equal to 0. X plus 2 equals 0. That gives me minus 2, right? X equals -2. That's one of my solutions. Okay. I put the x plus 3 equals 0. And again, -3, so x equals -3. And I put the x plus 5 equals 0, -5, -5, and that gives me x equals -5. So first of all, we find all the roots, okay? There are 3 solutions here. But I know I'm supposed to have 4 roots, okay? So we need to talk about multiplicity. That's where that comes in. And the multiplicity of each one depends on what it came from, okay? So right here, this x minus 2, or x equals -2, the multiplicity is the exponent on that factor. That's what we're looking for, okay? That's kind of my definition for multiplicity, okay? So the exponent on that factor, it came from a 1, right? So this x equals -2, he has multiplicity of 1, okay? So then I ask you, where did this x equals -3 guy come from? He came from this factor right here, right? Okay. The x plus 3 to the first power. What was the exponent on that factor? Just the one that we're looking at there, okay? He had a 1, right? Okay, so what's his multiplicity? 1, yes, good. I see it on a couple of hands, thank you. Okay, he has a multiplicity of 1. Okay. And then this last one, he has x equals -5, but look, he came from this factor over here, right? And what's the exponent on that guy? On that factor, it's a 2, right? Okay, so that's where we've got the extra root. He has a multiplicity of 2 because of this exponent, okay? So the exponent on that factor was a 2. That means he was a multiplicity of 2. What does that mean? This guy's a root once, or a solution once. The x equals -2. He's one solution. The x equals -3, he's one solution, okay? But the x equals -5, he's a solution twice, okay? So if we got in and started doing synthetic division and stuff, which hopefully we have time to do that today, then he would be a solution twice. So I would stick him in once, x equals -5, but then I could do it again and still get a 0 for the remainder, right? So he's going to work twice, and that gives me 1, 2, 3, 4 roots, okay? Because this guy is a solution twice. And I think that's what kind of messed some of us up on test 2, was that about multiplicity was, what do you mean he can be a solution twice? It's because that's 2 different factors, basically. Uh-oh, we lost somebody. Okay, 2 different factors. So we could have written this one, by the way, since it's squared. If this bugs you, you could write it x plus 5 times x plus 5, right? That's what x plus 5 squared means. So you can see it happens twice. Okay, the next piece of that says, does it cross or does it touch? If it is an even multiplicities bounce off the x-axis. And I'll show you the picture in a minute, okay? Even multiplicities bounce off the x-axis. So for purposes of the directions there, that would mean it touches it and then it goes away. Right, that's what that means. Okay, so that's if it's even. The only even guy we have is this one, the x equals -5. So that means he's going to bounce off, or he just touches. Okay. Odd multiplicities always go through. Go through the x-axis. Odd multiplicities go through the x-axis, okay? So in that case, the directions say, does it cross or does it touch? Well, it's going to cross through, right? That's their wording is slightly different than the wording I use, so I want to make sure we know the difference, but hopefully that makes sense. Touches is just it bounces off, and crosses is that it goes through. And if that's confusing on the final, you can always ask me. What do they mean by that? All right. Okay, and then the last little bit here says, well, Yeah, the last little bit here says, sketch the basic graph of the function by showing all the intercepts, which we have, and the end behavior of the graph. So that's where I'm going to stick it all together, basically, graph it all. So this looks like, here's my graph. All of my X-intercepts are on the negative side of things. I don't know if you noticed that or not. I've got a -2. I've got a -3. And I've got a -5. So those are all solutions. They're all X-intercepts. So they're all right there. Okay. I want to talk just a minute about end behavior. Okay. So end behavior is determined by two things. Okay. One is the degree of the thing. So degree here is 4. Okay. So that tells me it should go 4 different directions. Remember the basic one that is 4 looks something like this. Looks like a W. 1, 2, 3, 4. Okay. So it curves up and down. So that's the basic shape of the thing. And then the other thing I need to know is that it's the up, whether it's opened up or opened down, right? It could be opened down, in other words. Whether it's opened up or opened down, that comes from the leading coefficient, right? So in other words, if all of this stuff is positive from the get-go, okay, then it's going to look like the right side up W, right? So that's the positive. But if all of the stuff is negative from the get-go, then it's upside down. Kind of looks like an M, okay? So those two things are what tell me in behavior. I don't have to worry about anything else. So how many times is it bouncing around, basically? How many times is it up and down? And then is it positive or negative? So when I look at this equation way back here at the beginning, okay, it was X plus 2, X plus 3. This is positive out here, right? Okay. So because it's positive, that means it's going to look like the W. That's my end behavior. Okay. Then we're going to use all this stuff to make it work. So it's going to look like a W. It's going to go something like this. Okay. But this guy right here, the -5 guy, sorry, it's up here. X equals -5. He was multiplicity of 2. So he's the one that bounces. Remember, everybody else goes through. So we have to get that bounce in there, or the fact that it just touches and then goes away. So it's going to look like a W. It's going to be coming down like that. But instead of crossing through, it's going to bounce off. So he's going to come back up. Okay. But then -3, he had multiplicity of 1. So this was go through. I didn't write this. This was a cross. This was a cross. This is a bounce. Okay. So this one's going to go through at -3. And I also had -2. He was multiplicity of 1 and he goes through. So when I'm finished, hopefully it looks like the W. Okay. And he is opening up. And I'm going to tell you, those questions right there are kind of long questions, right? They take a while to do all of that stuff we just did. So you might see this split into multiple parts or multiple questions, and you'll have points assigned according to that, like how many parts, how many questions. Does that kind of sound familiar? That's one of those polynomial functions. I know it's been a bit. Okay. Nobody's saying anything, so I'm moving on. We only have a few minutes left, so let's at least get one rational function in. While I'm doing this one, I'm gonna do number 27. I'm gonna ask to you guys, did those 3 of you, did y'all manage to take your test yesterday? No. Okay.
She
so
wouldn't let us.
the sub wouldn't let you?
No.
Okay. I'm gonna have to try to figure that out because I need y'all's third test so that we can do your
We can try to
averages.
take it tomorrow if that sub's not here. But she
Okay.
isn't today. But yesterday she refused to let us take it.
Okay. Do you know who it is? Because I might be able to email her or something.
Are you going to be here tomorrow? No, we don't know who the sub is.
Okay. All right, well, maybe I'll email Miss Penny
Okay. Okay.
and maybe she can help with that. Thanks. I need y'all to get them done. I need to move on to final. Dang it. Okay. 27 says f of x equals x squared minus 6x plus 3 all over x plus 5. Okay. And this guy is a rational function. I know he's rational because of that fraction going on there. Okay. And so we have to worry about domain first and foremost. So domain, remember that the denominator can't be equal to 0. So x plus 5 is not equal to 0. So before you do anything else with a rational function, try to look at those things, right? What's my domain? So if x plus 5 can't be 0, then I know subtract 5, x can't be -5, right? Okay, that's my domain. So make sure you do that right up front and you've got that taken care of. And then they're asking me about horizontal and vertical asymptotes. They didn't ask me to graph this one. So I'm probably not going to sketch it because I'm not going to have time and that takes a long time. But horizontal and vertical asymptotes we can deal with, okay? So what we know is that vertical asymptotes happen at bad spots. That's a Webster term, sorry. Bad spots in the domain. Okay, so my bad spot in the domain, I already know what it is, right? I've already got x can't be equal to -5. Okay, the only thing I need to check for is that an asymptote or is it a hole? Okay, remember, if it's a removable discontinuity, I'm going to say bad spot, but the book will say discontinuity, then it's a hole. Otherwise, it's an asymptote. Okay, otherwise it's a vertical asymptote. So all you need to know is, does it go away or not? Okay, well, the way you know if it goes away or not is if there's something on the top that will cancel with it, right? And this is not. Even if I can factor this guy, which I don't think he does, he doesn't look factorable, but even if I could, one of them is not going to be a 5, right? Because things that multiply to give me 3 are 1 and 3. So this is not going to reduce, okay? So here we go, x equals -5. That's my vertical asymptote. Oh, x equals -5, okay? So remember when you were graphing that, if we were graphing this, we would come out to -5. Oh, it's -5. It would help if I went the right direction. And we would draw this dotted line for the vertical asymptote and we say, hey, that's one we're never going to cross because that's a bad spot in the domain. Okay, that's what's going on with vertical asymptotes. And then they ask about horizontal. Okay. Okay, and remember for horizontal asymptotes, there were actually 3 rules and they all had to do with your exponents. So, and I'm about to run out of time, I'm sorry. So if it's bigger on bottom, if the exponent's bigger on bottom, we get y equals 0, always. If it's bigger on top, then there's none, okay? And if they're the same exponents, you just do the leading coefficients divided by each other. Leading over leading. Okay, so those are my 3 rules. And this one's bigger on top, so what? No horizontal asymptote, right? Because this is a 2 up here and this is only a 1 on the bottom. So all we're doing is examining the exponents. So this is the no. None. No HA. All right, and I think I'm out of time. I think y'all are being kind and sticking around. Did the bell ring? No bell yet? How did that happen? It's always rung by now. I'm always like, ah, okay. So that is the big stuff for test 2 is the ratios, rational stuff. And looking at those, What we haven't done yet is one about synthetic division, and that's for sure gonna be there. So I will probably just make you a really short video about synthetic division and make sure you've seen that. All right, I'm sorry. Everybody have a great week, and hopefully we can get y'all's test taken. Bye, thanks.